Hey guys, welcome to day 6. We're going to be finishing our topic on scientific notation. We'll do a couple of examples from last time to remind us of how to both put something in scientific notation and work backwards to go from standard into from scientific into standard. And then we'll talk about operations using scientific notation. If you haven't taken a physics class yet, but intend to in the future, scientific notation and its basic operations are one of those things that if you know how to do them without a calculator, it really makes the math a lot easier to do and a lot less cumbersome when it comes to bigger problems. So let's take a look at a couple of problems from last time. To start off with, we'll do 2 of each, and then we'll look at operations using scientific notation specifically. There'll be a short homework assignment tonight, only a couple of problems, and let's get to it. So for today, let's look at 2 problems from last time. Let's take a look at this example. This is referred to as the world gross income. It is a metric that is calculated every single year, and this is the gross income from 2014. It is listed as the following value: 85, 500, 000, 000, 000, and that's our number. So across the world, the estimated income for the entire world is this big number. I'm not even going to try to guess what it is. It's big. We're going to convert this into scientific notation. Now remember, to convert into scientific notation, what you do is you want to make sure you have the following form: A times 10 to the n power, where A is between the values of 1 and 10, including 1 as a possibility. And so the best way to do this is by taking a decimal point and shifting it to either the left or the right until you get this A to work out. And so you can see that if I shift this decimal point to the left, I'll get closer and closer to one of these values that is between 1 and 10. So if I shift it to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. I have to shift 13 because I can't have 855 as my number because 855 is bigger than 10. I can't have 85.5 as my number because that's also bigger than 10. But I can have 8.55 as my number. So 8.55 times 10. And then if it's a large number, it's going to be positive. And we just tell how many spaces we move. So in this case, it would be 10 to the 13th power. So in other words, the world gross income in scientific notation is 8.55 times 10 to the 13th. And if you take a calculator out and actually do this operation, you'll get the same solution. Or more likely, your calculator can't display this answer because it's too big. And that's why scientific notation is so useful. Let's look at another example. Let's see. This is time for light to travel 1 meter. Now, many of you guys have probably heard of things like the speed of light from science fiction and movies and literature, but this is a number that is really useful if you're talking about something in a small scale. Speed of light's good if you're like in space, but if you're on Earth, you're not really talking millions of miles at a time here. So this number is 0.00000000334. Double check. Oop, I have 1 extra 0. Okay. So now we're going to convert this number into scientific notation. First, we look at where our decimal point is. We need to get this number so that the first number is between 1 and 10, including 1. Well, 0 is not between 1 and 10, so I can't accept that number, so I go 1 space to the right, 2 spaces to the right, 3, 4, 5, 6, 7, 8, 9 spaces to the right. Once I get to the 3 is between 1 and 10. I can't go any farther because then I get to 33, and that's not between 1 and 10. And if I go even farther than that, I get 334, also not between 1 and 10. So this is my clear stopping place. The first time you encounter a number that is between 1 and 10, including 1, you have to stop. So this becomes 3.34 times 10. Now I moved 9 spaces to the right, which means this would be negative 9. Also from last time, you need to have the other ability, where if I give a number in scientific notation, you'd be able to write it in standard notation. So let's look at 2 more examples from last time. Let's call them C and D. All right, C, 7.91 times 10 to the negative 7th. Okay, let's talk about how to convert this into standard notation. So, first of all, I need to look at this, and it's easiest if I do it based upon the sign first. So I see this is a negative 7. This tells me I'm going to move my decimal place to the left. Remember, negative is usually to the left, positive usually to the right, or unless you're doing it the other way, in which case it should be reversed. So, this tells me I'm going to have 791, but the decimal place is going to be moved 7 places to the left. So you take that process. Originally, the decimal place was here. Now I'm going to move it 7 places to the left. 1 place, 2 places, 3 places, 4 places, 5 places, 6 places, 7 places. And it's typical to put a number in front. So I end up with 0.123456791. You'll notice that the number of zeros is 1 less than the power. That is because we have to move it past the 7 as well. And so that 7 is one of the numbers that I have to count. And so I have 6 zeros plus the number 70, a total of 7 zeros. Going the other way, let's say I have something like negative 2.03 times 10 to the 6th. Okay, just like before, we're going to go do it in scientific notation. Now when I do it in scientific notation, I look at the sign first. It's a positive 6, so that tells me it's going to move it to the right. So I start off with negative 2.03. Now I need to move it 6 places to the right. So 1 place, 2 places, 3 places, 4 places, 5 places, 6 places. So I end up with negative 203 with 4 zeros. 1, 2, 3, 4. I almost put the number 4. And this should be that number in standard notation. Notice that again, the decimal place moves 6 places to the right because it is a positive 6. And this one it moves 7 places to the left because it is a negative 7. And there we have it. That's our material from last time. Let's now talk about today's material, which is doing the same process, but now with an operation involved. For this, we're going to do 5 examples. And we're going to talk through each one as we go and kind of discuss, how they work and why they work and kind of just fit them together. So let's get some examples up here. A, B, C, D, and E. All right, A. We're going to take 8.14 times 10 to the negative 7th times 6.5 times 10 to the 10th. This is a common type of problem you'll see in advanced physics, or even in basic physics, where you're dealing with incredibly large or incredibly small values being multiplied or divided together. And if you know your algebraic operations, we can do this relatively quickly, even without much help from a calculator. Because again, your calculator has difficulty displaying a number like 10 to the 10th. It just doesn't like it. It's not saying you can't do this with a calculator, but being able to do it by hand means you have the ability to do it not just with numbers, but with variables as well. So let's take a look. So remember from before the commutative property, or the associative. I always get those two backwards. It's one of those two. What the property states is I can take this in any order I want. You'll notice that there are 4 things that are all being multiplied. 8.14 is one thing. 10 to the negative 7th is a second thing. 6.5 is a third thing. And 10 to the 10th is a fourth thing. They're all being multiplied in their own order. Meaning that one of the things that I can do, because of that property, is I can switch the order to any order I want. Meaning these two numbers that are out front for the 2 terms, I'm going to choose to put those together in their own operation. And the other 2, I'm going to do them separately. 10 to the negative 7th and 10 to the 10th. Why would I do that? Well, because if you look right here, this operation can be solved using the properties from last time. We have 10 to the negative 7 times 10 to the 10th. Those two have the same base, meaning that for this problem, I can rewrite this as 10 to the negative 7 plus 10, or 10 to the third. I'm allowed to take that operation where I can switch the order as long as they're all being using the same operation, they're all being multiplied. I can switch the order around, allowing me to take these two separately from these two, but these two I can use a property to get the answer faster. Like, even if you type this into a calculator, if you type this into the calculator, it takes longer to type this in than it does just to subtract those two numbers. Now, the 8.14 times the 6.5, this is where a calculator is very helpful. So I'm going to use my calculator on my computer, but you can use any calculator that you have. I'm going to take 8.14 times 6.5, and what I end up with is 52.91. So I end up with 52. Now, if I start the problem in scientific notation, I should always make sure to end the problem in scientific notation. It is a property of mathematics that whatever language you start in, you should finish in. It makes a lot of sense whenever you think about it in terms of, anything else. If your conversation's like starting in Spanish and you flip to English for some reason, you should probably end it in Spanish. Like, it makes sense based upon what's going on. In this case, I need to make sure this is in scientific notation, which it is not. 52.91 does not match this form. 1 is less than or equal to A is less than or equal to 10. 52 is not between 1 and 10. And so what I can do is I can take one extra step. I'll have to move this over one more place. Now, since I'm moving it to the left, that's going to make this number for 3 go up one more, meaning this becomes 5.291 times 10 to the 4th. If you're not sure whether you should add or subtract, one of the things you can do is take this and convert it into standard notation. 52.91 times 10 to the third would be 52910. And so one of the things you can do is convert to standard, and then convert again. Because if you're having trouble getting this to become this, then you may want to convert back into standard, because standard is easy to convert once you've done it a couple times. So that's the operations you have at the second part of your homework assignment. Homework will fit into two categories. It'll fit into ones that involve your standard can you convert, and then ones involving operations. Let's look at our second example now. In our second example, we have 4 times 10 to the 5th divided by negative 1.52 times 10 to the 9th. Okay, just like before, one of the things I'm going to do, I have the option to rewrite. And so for this problem, I'm actually going to rewrite in the following way. I'm going to write as 4 times 10 to the 5th divided by negative 1.52 times 10 to the 9th. Now, because there's a separate symbol in between these two, I can't just rearrange like it did up here. That doesn't work. But what I can do is, when it comes to division, it doesn't matter whether I divide. Okay, I'm going to have to do this very lightly here. I could divide the entire thing by the entire thing. That's one option. But because of how multiplication works, I could also just divide these two. And just divide these two. As long as I end up dividing, because they're being multiplied, the order isn't as important as it seems. And I can even go the other way. Like, I could try to cross divide, where 10 to the 5th divided by negative 1.52, or 4 divided by 10 to the 9th. I can choose any one of the ones on top can be divided by any one of the ones on bottom, as long as I end up dividing both. And so this allows me to think of this not as one fraction, but as 2. 4 over negative 1.52 times 10 to the 5th over 10 to the 9th. Notice how I can rewrite this function from the original form over to this form, but this one I can apply rules to. Let's take a look. On the right-hand side, I have 10 to the third divided by 10 to the ninth. Remember, division becomes subtraction. So this will become 10 to the 5 minus 9, which will eventually become 10 to the negative fourth. I can also do 4 divided by negative 1.52. That's a calculator piece that I don't want to do by hand. So let me grab a calculator. 4 divided by negative 1.52. I end up with, let's see, it is negative 2.632. And so I can get to my answer. I always want to make sure it is in fact finishing in scientific notation. So 632, and there is my solution in scientific notation. So notice how we can take the original problem, we can rewrite it. With that rewrite, I can regroup them using algebraic properties, and then simplify one side by just standard division. That's easy. But the other side I can use a property on. So notice how I take this complicated problem with 4 different components and 3 different operations and break it down into 2 much simpler problems, one of which I can do with a calculator, one of which I can do with some basic rules. This is the advantage of having these kinds of skills, is that you can look at them and try out these different ideas to get to your solution. Let's do a couple more. Get a lot of practice with this. So do 2.7 times 10 to the fifth times 6.04 times 10 to the negative 13th. Okay, let's do this. One of the best things you can do, and you notice how I have the commutative associative property kind of up here as like an option, but remember, this is just a form of rewriting the problem. And so I like to think of it as both of these are just rewriting the problem, and that is a great first step to take. So that's what I'm going to do. I'm going to rewrite the problem. So because they're all being multiplied, I can rewrite the problem as 2.9 times 6.04 times 10 to the fifth times 10 to the negative 13th. It gives me the option to try it that way. Now, the first piece, 2.9 times 6.04. Calculator is helpful for that simple basic math. 2.9 times 6.04. We end up with 17.516 times. We have 10 to the fifth times 10 to the negative 13th. Multiplication becomes addition. So 10 to the 5 plus negative 13. Now, 5 plus negative 13 would be 17.516 times 10 to the negative 8th power. Now, this is not in scientific notation. I have to remember the first number needs to be between 1 and 10. 17 is not between 1 and 10. So, I need to take this, I need to move this decimal place one space to the left. Now, when you're looking at a number, if you're ever confused, let me showcase that process. If you're ever confused about which way that's going to change this number, is it going to make it a negative 9 or is it going to make it a negative 7? Because that's the only thing that can happen, right? I'm moving one space, so it's going to change this number by 1. What you can do is you can always be like, okay, well, let me take 17.156, 516 times 10 to the negative 8. That's going to take me and do 1, 2, 3, 4, 5, 6, 7, 8. Load my decimal place right here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 shifts that I've done. And now I can basically come back and be like, okay, well, what if I wanted to put it back in scientific notation? Well, to put it back in scientific notation, we'd have to do 1 hop, 2 hop, 3 hops, 4 hops, 5 hops, 6 hops, 7 hops. So 1.7516 times 10 to the negative 7th. You have to be able to go from 17.516 times 10 to the negative 8th to this one. How you do it, I am not as concerned with, but you've got to be able to get to this answer that is in scientific notation. If you really wanted to, you could, in theory, start at the beginning and convert them all into standard notation. But it is a pain. It is far better to do it here when it's much more simplified than it is to try to bother to do it in the beginning. Okay, 2 more examples. Let's do one more division problem. So we get 2 each. 1.2 times 10 to the 8th divided by 9.6 times 10 to the 4th. Okay, just like before, I'm going to start the problem by rewriting. So I get 1.2 times 10 to the 8th divided by 9.6 times 10 to the 4th. I can then take that function. I can rewrite it as 2 separate functions. 1.2 over 9.6 times 10 to the 8th over 10 to the 4th. From here, I can simplify. 1.2 divided by 9.6. Calculator was helpful there. 1.2 divided by 9.6 is 0.125. 10 to the 8th divided by 10 to the 4th would be 8 minus 4. Remember, division becomes subtraction. And because of that, we end up with 0.125 times 10 to the 4th power. This number is not between 1 and 10, so again, I have to make sure to finish the problem. In this case, I need to move this statement 1 space to the right. Now, I can use previous ones to be like, hey, I added 1 when I moved it to the left, so I should probably subtract 1 when I moved it to the right. Or I could, again, convert this back into standard form. To convert it back into standard, I'd put 0.125, and then move it 4 decimal places. 1, 2, 3, 4. So we end up with 1,250, which in scientific notation is 1.25 times 10 to the 3rd. But you've got to be able to get to that solution. Now, one last thing, because there is one like it in your homework. What if there's more than 2 things? What if you have something like 3.33 times 10 to the 4th times negative 1.05 times 10 to the 7th times 5.62 times 10 to the 5th. When you have more than 3 things, you can take the same step of reorganizing and rewriting with the 3 things instead. So for example, the way to rewrite this one would be, I take all the front numbers, 3.33 times negative 1.05 times 5.62. I multiply all that by all the back numbers. 10 to the 4th times 10 to the 7th times 10 to the 5th. And I can do it in simply 2 stages. The left stage is one problem, the right stage is a different problem. The left stage is a calculator problem. So I pull up my handy dandy calculator. I do 3.33 times negative 1.05 times 5.62. And I end up with negative 19.65033 times, this would be 10, remember multiplication becomes addition, so that'd be 4 plus 7 plus 5. When you add all those numbers together, you end up with negative 19.65033 times 10 to the 16th power. The fact that it's negative doesn't matter. It's the same rules, even when it's negative. What matters is the powers. If the powers are negative, it changes things. But if the number is negative, it doesn't change anything. Now, just like before, I have to make sure it is, in fact, in my standard form for scientific notation. So I'm going to take this problem and actually convert it to the correct form, which in this case would be, I have to move this decimal place 1 place to the left. which would mean that I end up with negative 1.96533 times 10 to the 15th power. See, even I sometimes mix these up. I have to think to myself, if I want to move it to the left, what happened to the number? I had to add 1 to, oh, it should be to the 17th power. If that fails, if you ever have trouble getting to that solution, just convert it. This is negative 19.65033. Well, I just move this 16 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I can just work my way backwards. Like, it works. It's tedious, but it guarantees that you get the right answer, which you need to. So, that's it. Your entire homework assignment is based upon those two things. Can you convert from standard into scientific? Can you convert from scientific into standard? And can you do basic multiplication and division with scientific notation? Well, that'll actually be it for today. I'm going to finish up a couple minutes early. That'll make up for how many minutes late I was yesterday. But that's it. Hope you guys have a good rest of the day. We'll have our next assignment on Thursday, and I'll see you guys then.